Good day, grade 12 learners. Welcome to today's physical sciences lesson. My name is Amen Mkize. Remember, this lesson is brought to you by Gauteng Department of Education in collaboration with Saibono Discovery Center. Remember, grade 12s, you can interact with us via WhatsApp. The number is 079 578 2908. Remember, if you want to interact with us, you can only interact with us via WhatsApp. And please, learners, don't send the voice notes, the voice calls, the videos. You can just type and then we'll be able to assist you. Right. Learners, today we are going to focus on electric circuits, right? And remember, electric circuits, that is part of your paper 1 under knowledge area, electricity and magnetism. And then electricity and magnetism, remember, it covers 55 marks when it comes to your paper 1. Remember, topics under electricity and magnetism, it's your electric circuits, your electrodynamics, and your electrostatics. And then those 3 topics, the total will be 55 marks when it comes to your paper 1, right? So today, remember, you started with electric circuits, if I'm not mistaken, maybe in grade 9, right? Grade 10, you also did electric circuit. Grade 11, you did electric circuits. And then even in grade 12, you are going to do electric circuits, right? But with grade 12, remember, we'll be dealing with what electric circuits where there is internal what resistance, right? Let's start with our examination guidelines, which I believe all of us, we have it, right? So this is what you need to know under electric circuits, learners, right? 1, stating Ohm's law correctly. And please, learners, use your examination guidelines to define the terms given to you, all right? So 1, it is your Ohm's law, which is stated as the potential difference across a conductor is directly proportional to the current in the conductor at a constant what temperature. So learners, this is how we have to state what Ohm's law, all right? Then again, another thing that you need to know under electric circuits, it's to determine the relationship between current potential difference and resistance at constant temperature using a simple circuit, right? State the difference between ohmic conductors and non-ohmic conductors and give examples. So by now, I think you did that in grade 11. You know what is an ohmic conductor. Remember, an ohmic conductor, that is the conductor that obeys Ohm's law. All right. Then a non-ohmic conductor, that is a conductor that does not obey what Ohm's law, right? Even if they can say define an ohmic resistor, maybe instead of saying ohmic conductor. So ohmic resistor, that is a resistor that obeys what Ohm's law. Non-ohmic resistor, that is a resistor that does not obey what Ohm's law. Then again, you'll be required to solve problems using the equation R equals to V over I for series and parallel watt circuits, and then the maximum of 4 resistors will be given, right? So in other words, you won't get a circuit where we're having 5 external watt resistors. So the maximum should be 4, excluding the internal watt resistance. Then another thing that you need to know under electricity or electric circuits is to define power as the rate at which work is done. And remember, power can be calculated using the equation work done over change in T, all right? And then you can also use P equals to VI, P equals to I squared R, P equals to V squared over what? Over R. So these are the equations, learners, that you can use, or this is the formula that we can use to calculate what power. And there's no need actually, learners, to memorize these equations. They are there on your formula sheet. So we'll also talk about that later, right? And you must be able to solve circuit problems involving the concepts of power and electrical energy. We are going to do that. Deduce that the kilowatt hour, which is kWh, refers to the use of 1 kilowatt of electricity for 1 hour, all right? Calculate the cost. You must also know how to calculate the cost of electricity usage given the power specifications of the appliances used, the duration, and the cost of 1 kilowatt hour, all right? So it's what we are also going to focus on. Then internal resistance, series and parallel networks, solve problems involving current, voltage, and resistance for circuits containing arrangement of resistors in series and in parallel. And the maximum, already I've talked about that. The maximum should be 4 resistors, excluding the internal resistance. And again, you must also know how to define the EMF, all right, as the maximum energy provided by a battery per unit charge passing through it. So that is how you have to define EMF of a cell or the EMF of what? Of a battery. Then solve circuit problems using the equation EMF equals to external potential difference or V load plus lost volts or internal potential difference. You can expand that equation as E equals to IR external plus IR internal, all right? Solve circuit problems with internal resistance involving series parallel networks of resistors, and then the maximum is also for them, all right? Yeah, so that is what you need to know when it comes to electric circuits in grade 12. But another thing that is important, learners, is that whatever you did in grade 10, right, under electric circuits will be tested in grade 12. What you did in grade 11 under electric circuits will also be tested in what? In grade 12. And grade 12, we are only going to focus on what? On electric circuits with what? Internal what? Resistance. Okay, it's what we are going to include, or it's what we are going to add now when it comes to grade 12. Then, internal resistance, learners. If you are talking about internal resistance, what are we talking about? Like other components, they have resistance, right? Like conductors, they have resistance, all right? A bulb, it has resistance, a switch, an ammeter, a voltmeter, all those components, they have what? Resistance. So like other components, a battery has resistance, right? Remember, when it comes to a battery, there are charges, and those charges are in motion, all right? So remember, they always move from what? From the negative plate or the negative terminal to what? To the positive terminal. So as they move within the battery, they experience what? The resistance, all right? So that resistance, actually, we call it what? The internal what? Resistance. So if we are talking about the internal resistance, that is the resistance inside what? The battery, or the resistance of what? Of a battery, or the resistance of what? Of a cell, right? So that is actually internal what? Resistance. Then batteries, learners, they have internal what? Resistance. I've explained that. A cell or a battery has what? Internal what? Resistance. So I've alluded to that. And then remember, learners, if which is what you did in grade 10 or grade what? Grade 11. Remember, grade 10, we're just focusing on circuits where there's no internal resistance, but we were just ignoring it. We are not saying batteries, they don't have resistance, all right? So we are focusing on what? On electric circuits where there was no internal what? Resistance. Even in grade 12 learners, they can also give you a circuit where there's no internal what? Resistance, or where the internal resistance of a battery or a cell is being what? Ignored, all right? So that is why I said to you, whatever you did in grade 10 will be tested again in grade 12. Whatever you did under electric circuits in grade 11 will be tested in what? In grade 12. So what are we adding here is only what? The internal resistance. So in an exam, don't just expect, a circuit where there's internal resistance. You can also get a circuit where there's what? Where there's no what? Internal resistance, or where the internal resistance is being what? Ignored. Just a reminder again, learners, remember, if there is no internal resistance, or the internal resistance is being ignored, the voltmeter connected across the terminals of a battery, it's equals to the EMF of what? Of a battery, if there is no internal what? Resistance. But if there's internal resistance, it's a different story, all right? So, but if there's no what internal resistance, or the internal resistance is being ignored, right? So the terminal potential difference is equals to what? EMF, if there's no internal what? Resistance. But if there's internal resistance, then it will be what? A different story, right? So which is what we are going to talk about, all right? Then the potential difference across the terminals of a battery is sometimes referred as terminal what? Voltage, or terminal potential what? difference. So remember, it is equals to EMF if there is no internal what resistance. But if there's internal resistance, you will see what will happen. All right. So let's focus on that one. But before we focus on that, by now we know that a real battery is the what internal what resistance. Why we have that internal resistance? Remember, there are charges inside the battery that are in motion. So as they move, they collide with each other. Hence, they will experience what resistance, and that resistance we call it what the internal what resistance. But then, as if they say define internal resistance, right? Remember what is resistance, right? Resistance, that is the opposition of the flow of what of current, right? So which means that when you define your internal what resistance, you can say it is the opposition of flow of current in what in a battery or inside what a battery. So that is how you have to define the internal what resistance. Although that definition is not there on your examination guidelines, but you can't say internal resistance is the resistance. So that is redundant, right? So rather it will be the opposition of the flow of current in what in a cell or what or a battery. So that is how you have to define the internal what resistance as the opposition of the flow of current in what in a battery or in what in a cell or inside a battery or inside what a cell. So that is how we have to define what the internal what resistance. Then your data sheet learners, right? So under electric circuits, we have these equations. So already you know this one, R equals to VI, where R is what? Your resistance, okay? V is the potential difference of voltage, and then I is what is the current. R, remember, is measured in ohms. All of us, we know that, okay? V is measured in what? In volts. Then I is measured in what? In amperes, all right? Then we have this one. If there is internal resistance, I will explain more. E equals to I into R plus a small letter r there. And then we know this equation, learners, right? Rs equals to R1 plus R2, right? Remember, we use this equation to calculate the total resistance for resistors connected in series, all right? And then this one, we use it to calculate the equivalent resistance or the effective resistance or the total resistance for resistors connected in what? In parallel. So what is important here, learners, make sure that you trace current. So if current moves as one, remember those resistors will be connected in what? In series. But if current splits, right, or if current is divided, then those resistors will be connected in what? In parallel. Then if they're connected in parallel, you can't use Rs equals to R1, R2 to calculate the effective resistance or to calculate the total what resistance. Rather, you have to use 1 over Rp equals to 1 over R, 1 plus 1 over R2, okay? That equation is for resistors connected in what? In parallel. So it's very, very important to detect whether the resistors are connected in series or they are connected in what? In parallel, right? And again, remember, if resistors are connected in what? In series, right? Grade 10, I think you did this in grade 10, right? If resistors are connected in series, remember they divide the potential difference, right? But the current is the same, okay? So irregardless of their resistances, whether you're having 100 ohm resistor, you know, in series with what? With a 1000 ohm resistor, what will be different there? It will be the potential difference, but the current will be the same, irregardless of their resistances. So I hope you will still remember that. So what is constant when it comes to resistors connected in series is current, right? What is divided, it is the potential difference, right? Then if the resistors are connected in what? In parallel, for resistors connected in parallel, what is constant for resistors connected in parallel? You did this in grade what? In grade 10, right? So for resistors connected in parallel, what is constant? It is the potential difference, irregardless of their resistances. Whether we are having a 90 ohm resistor connected to connected in parallel to a 1 ohm resistor, all right? So since they're connected in parallel, then what will be constant? It will be their potential what difference. So the potential difference will be what? Will be constant. But what will be divided? It is the current. All right. So very, very important. So I hope you still remember that. Okay. Another equation. This is the equation, learners, if you still remember again in grade 10, that we can use to calculate what? Charge. All right. Charge, remember, is measured in coulombs, and then I, that is current there, and then T, that is time, which is measured in what? In seconds, all right? So you can use that equation to calculate current given charge and time. You can use that equation to calculate charge given I and what and change in T. All right. Then this equation, if you still remember in grade 10 again, this is the equation that we can use to calculate what the potential difference, right? The potential difference across a certain component, maybe for example, across what a resistor, right? So we can use V equals to what here, work done over what, over charge, all right? So I hope you still remember that equation. So this equation, we can use it to calculate the potential difference across a certain resistor, for example, and then that W is what is work done, which is measured in joules, and then Q, that is what charge, which is measured in what, in coulombs, all right? So we can also use it to calculate work done, to calculate energy dissipated by a certain component, right? So using it as work done equals to VQ, where V is your potential difference, and then Q is what is charge, which is measured in what, in coulombs, right? So then these are the equations again, learners, that we can use. But before these equations, let's start with these ones. Already I've talked about this according to your examination guidelines. This is how we can calculate power dissipated, or power dissipated by a certain component, power what delivered by the battery. Okay, so P equals to work done over change in T, or we can use P equals to VI, P equals to I squared R, P equals to V squared over what, over R. And remember, power, learners, is measured in watts, right? Power is measured in watts, so I hope we are all aware of that. So yeah, then these are the equations, learners, that we can use to calculate electrical energy, what are transferred, or what electrical energy used, all right? So this is energy or work done, all right? And remember, this is measured in what, in joules. So this is how, these are the equations, learners, that we can use to calculate what, energy. So I hope we are aware of this, or we are aware of these equations, all right? They are there on your data sheet, so there's no need for you to memorize them, learners. So you should know that they are there, all right? And if you're given a question and the question requires you to use these equations, do not, manipulate that equation first. What is it that you need to do? You copy the equation as it is, and then from there you can manipulate it. Or even if you don't manipulate it, it doesn't mean that you're not going to get the correct answer. So rather, stick to what is given to you and you copy that as it is. Remember, we don't give marks for manipulated equations, all right? First thing that you need to do, you write the equation as it is, okay? So you know why I'm saying that? Because in most cases, you'll find learners, when it comes to this equation, learners, right? You'll find them using what, RP. I'm not saying it's wrong, right? So they will say maybe RP equals to 1 over what, over R1 plus 1 over what, over R2, and then to the power what, -1, okay? So learners, we don't give marks for such equations. Where are they coming from, right? So rather stick to your examination, sorry, not your data sheet, you know? So copy those equations as they are, all right? Then these are other equations that are very, very important when it comes to your electric circuits, right? So this is one of the equations that we can use to calculate what is the total current in a circuit. So which will be your V external potential difference divided by external what, resistance, all right? Or R load, okay? Another equation, I total equals to V total. V total, remember this one is it's what is the EMF. So over what? Over R total, okay? Then I total lost volts over what? Here it's supposed to be lost volts over what? Over small letter r, not R external, okay? So it's V internal or lost volts over internal what? Resistance. So these are equations that we can also use, but they are not on the formula sheet. They are not there on your data sheet, but you can use them. They are very, very useful when it comes to your electric circuits, all right? Okay, we have talked about formulae or the data sheet. Now, so that you'll understand what happens to a circuit if now internal resistance is not ignored, right? So remember, learners, if the internal resistance is what is ignored. For example, in this case, you are given what? The EMF, all right? You are given the EMF of this battery. Why am I saying this is a battery? Remember, 2 or more cells, they form what? A battery. How many cells are there? There are 2, and those cells are connected in what? in series, right? So since we're having 12 volts there, it means that each cell has an EMF of 6 volts. So 6 plus 6 will be what? 12 volts, right? So if the internal resistance is ignored, so if you're having 12 here as our okay, so if you're having 12 here, 12 volts as our EMF, right? If internal resistance is ignored, this V was going to be what? 12 volts, all right? So EMF here will be equals to terminal potential what? Difference. If internal resistance is what is ignored. So this is what we did in grade what? In grade 10, grade 11, all right? So EMF will be equals to the terminal potential what? Difference if what internal resistance is what? Is ignored, all right? But in this case, the internal resistance is not ignored. It is there. So this is how we represent a circuit where there is internal resistance. So this small letter R, learners, shows that there is internal resistance. This cell or this battery has internal what? Resistance. So this is how we show it in what? In an electric what? Circuit, okay? Then the EMF of this battery is what? Is 12 volts. And this battery has what? An internal what? Resistance. By now, you know what is an internal resistance. That is the opposition of the flow of current in what? In a cell or in what? In a battery. All right. Then learners, what you need to know, if there is internal resistance, a circuit now will be divided into two. All right. You are going to have what? The internal circuit, which is the battery there. This will be your internal what? Circuit. Right? This will be your internal what? Circuit. And then anything outside the battery will be the external what? Circuit. When are we going to have two circuits in one, the internal and the external? If internal resistance is not ignored, all right? So if internal resistance, learners, is not ignored, right? You are going to have how many circuits in a circuit now, or in one circuit, you're going to have two circuits, right? The first one will be the internal circuit, the battery, and then anything outside the battery, then that will form part of what? Of the external circuit, all right? Then, now, what is important here, all right? Let's say you are having, so that you'll understand this better, all right? Let's say you are having what? A voltmeter, right? This voltmeter, right, sorry about that. Right, so you are having this, what? You are having a voltmeter there connected across the terminals of the battery, all right? And let's say the switch here is what? Is open. So you're having an open switch, right? So obviously there is no flow of what? Of current. So let's say this is your V1, and then maybe this one would be your what? Your V2. So you're having V1 across what are the terminals of the battery, and then we're having V2, which is across that external what? Resistance, right? And the switch here is what? Is open. So if the switch is open, obviously there's no flow of what? Of current, right? So your V1, remember, is connected across the terminals of the battery, and then there's no current that is flowing. So what will be the reading on V1? The reading on V1 will be what? Will be 12 volts, right? Okay? If the switch is what? Is open. What will be the reading on V2? There's no current that flows through R external. So since the current is zero, what about the potential difference? The potential difference across that resistor will be what? Will be zero. So your V2 learners will be what? Will be 0 volts. Okay? So 12 volts for the battery, all right? Since the voltmeter is connected across the terminals of what? Of the battery. Okay? Then what about the potential difference across that R or R external? It will be what? 0 volts. Remember, there will be no current that will pass through. I'm saying the switch is open, right? The switch is open, so since the switch is open, no current that will pass through R external. So since there's no current passing through, then what about the potential difference across that resistor? It will be what? 0 volts. I hope we are following, all right? Then now, we close the switch. For example, this circuit that is given to you, right? The switch was closed, all right? So let me read the statement. In the circuit below, the battery has an EMF of 12 volts and the voltmeter reading of 10 volts. So where is this voltmeter? Can you see that the voltmeter is connected across that R external, okay? So it's the voltmeter that they are talking about, so it's 10. Remember, learners, if there was no internal resistance, or if internal resistance was ignored, the potential difference, the EMF was going to be what? The reading on what? On the V1 was going to be equal to what? V2, all right? So, but in this case, can you see that your V1, which is the EMF in this case, will be what? 12 volts. But look at your V2. They're saying your V2 is what? Is 10 volts. So can you see that now there's that voltage drop, right? So there's that voltage drop. Why there's that voltage drop is because of the internal what? Resistance. It's no longer 12, 12. If it was going to be 12, 12, if the internal resistance was what was ignored, but the internal resistance now is not ignored, so it will be what 12 and what in this case 10. So can you see that there is that voltage drop? So why there is that voltage drop? Because they will ask you why there's a decrease in the voltmeter reading. Okay, the reason being it will be what the battery has internal what resistance, which means that some of the volts will be used by the battery itself, right? So for example, learners, if you go to a shop and then you buy a cell or a battery, right? You buy what? A cell with a certain EMF, right? So you come with it. Let's say, for example, you buy a cell with an EMF of 12 volts, right? So you come with it, all right? You connect the voltmeter across the terminals of that battery. What are you going to get? You are going to get 12 volts. But now, if this cell or this battery is connected to a circuit and there's flow of current, there will be that voltage drop. Why voltage drop? Because a battery has internal what? Resistance. So some of the volts will be used by the battery itself. All right. So which means that if a battery has 12 volts, right? That 12 won't, if there's internal resistance, right? So instead of a battery giving us 12 volts as it is for parts that are outside the what? The battery, okay? There's no way that it will give us 12. Reason being is because it has internal what? Resistance. So in this case, right, you are having 12 volts as the EMF, right? Then because the battery has the internal what? Resistance. So some of the volts will be used by the battery itself. That is why in the external circuit we are having what? 10 volts. So what happened to that 2 volts? It was used by what? By the battery. So you must be able to explain why there is that voltage drop. The reason is because of the internal what? Resistance. That is very, very important. Right. So let's look at this circuit. So what is the EMF? The EMF is what? It's 12 volts, and then V external is what? It's 10 volts. So I said to you, if what there is internal resistance, right? There will be 2 circuits, all right, which is going to be what? Your internal circuit, your battery, and the external what? Circuit. So your EMF now, learners, will be divided, okay? Some of the volts will be used by components outside the battery, or some of the volts will be used by what components in the external circuit, right? Where you'll have your what here, which is what we call V external, right? And some of the volts will be used by the battery itself, okay? Then this is what we call V internal, all right, or V lost, all right? So V external, or this is V load. So this is what is going to happen now if there is internal what? Resistance. So your EMF now will be divided. Very, very important. So we are not saying the EMF will change, right? The EMF remains constant. If there was no internal resistance, then in the internal circuit, it was going to be what? 12 volts. Even in the external circuit, it was going to be what? 12 volts. But because of the internal resistance, some of the volts will be used by the battery itself. So instead of a battery giving us 12 volts, it will give us something less than 12 volts. Why? Because of the internal what? Resistance. For example, in this case, 12 volts, that is the total. But the battery gave us what? In the external circuit, 10 volts because of the internal what? Resistance. So your EMF now will be divided into 2, which will be your what? Your V external plus your V what? Your V internal. All right. So the lost volts, those are the volts used by the battery, or is what? The internal what? Potential difference, or internal what? Voltage. Okay. So this is what is going to happen now. All right, it's no longer EMF equals to a terminal potential what? Difference. It's EMF now equals to external potential difference plus what? internal what potential what difference. All right. So let's check here. What is given here is the EMF. All right. And we are also given the external what voltage, which means that we can get lost volts. All right. So how are we going to get lost volts? Remember the EMF learners is what is 12. All right. And then V external. All right. We are given what the 10. Then this will be plus V what V lost. Okay. So our V lost in this case will be what 12 minus what minus 10. So what is 12 minus 10 is what is 2 volts. All right. So now what are we having? We are having EMF. We are given that. We are having external potential difference. And remember, the external potential difference will be used by components outside the battery, or it will be used by components in the external what circuit. So that is the potential difference that will be used by components in the external what circuit. Then if you talk about what internal voltage, that is what the voltage or the potential difference used by the battery. Okay, so those volts are called what lost volts or internal potential what difference. All right. So I hope we are together in this, learners. If there is internal resistance, there will be 2 circuits now. The internal circuit and the external what circuit. All right. So the internal circuit, the battery, right? So where you are having what the EMF and also what the internal what resistance, and then the external circuit, for example, in this case where we are having the ammeter reading there, so the ammeter there, right, and that external what resistance. So that is our external what circuit. Then now when it comes to your EMF, right, your EMF now will be divided into what? Into V external and V lost. V external potential difference that will be used by components in the external circuit. V internal used by what? The battery. Okay, so this is what is going to happen. Right, first question, they want us to define the EMF. So to define EMF, learners, you use your examination guidelines. Let's go back to the examination guideline. All right. Right, so according to our examination guidelines, right, EMF is the maximum energy provided by a battery per unit charge passing through it. Okay, so this is how we have to define what the EMF. All right, define EMF as the maximum energy delivered by the battery per unit charge passing through it. Okay, let's go to that slide now. Okay, then second question, what is the meaning of 12 volts? You are not going to say 12 volts is EMF. Already we know that it is EMF, and we know what is EMF by now. All right, so the symbol for EMF, remember, learners, we use E, this E, right? So EMF, we use this E, right? And remember, it is measured in what? In volts. I hope we are all aware of that. All right, so we know what is EMF, but now they want the meaning of EMF of 12 volts. What is the meaning of 12 volts? Learners, you must know that. All right, so the meaning of 12 volts, remember, this is potential difference, and then remember, potential difference is work done over what? Over charge. All right, so if you're having work done over charge, potential difference, that is the amount of work done per unit charge. All right, so if you're having 1 volt, remember, work done there is measured in what? In joules, and then charge is measured in what? There, in coulombs. So which means that here we are having what? Joules per what? Per coulomb. All right, so 1 volt is equivalent to what? To 1 joule per what? Per coulomb. You should know that. So 1 volt is equivalent to 1 joule per coulomb. Where are we getting that from? We are getting that from the equation. So 1 volt is equivalent to what? To 1 joule per what? Per coulomb, learners, right? So if you're having 12 volts, right? 12 volts, right? 12 volts is equivalent to what now? To 12 joules per what? Per coulomb, right? So if they say, give us the meaning of 12 volts, give us the meaning of what? Of 10 volts. 10 volts, 12 volts is equivalent to 12 joules per coulomb, or 10 volts is equivalent to what? To 10 joules per what? Per coulomb. What is the meaning of that, right? It means that each coulomb of charge, right? So it means that 12 volts, remember it's equivalent to 12 joules per watt per coulomb, right? So each charge carries 12 joules of energy. Remember, they're saying 12 joules per coulomb of charge. So each charge carries 12 joules of what? Of energy. So each charge per coulomb, each charge carries 12 joules of what? Of energy. So you must know the meaning of that. So you can't say 12 volts, it's EMF. Already we know it's EMF, but what is the meaning of 12 volts? 12 volts is equivalent to 12 joules per watt per coulomb. So each charge carries 12 joules of what? Of energy. All right. So if you're having 220 volts is equivalent to 220 joules per coulomb. So it means that each charge carries 220 joules of what? Of energy. That is very, very important. So learners, you must know that. All right. Then calculate the resistance of R if the reading on the ammeter is what? Is 2 amperes. All right. So what is important here, learners? You need to trace current. So when you trace current here, you'll see that current flows as one. Even when it comes to this resistor, it's still flowing as 1. And then the ammeter there is flowing as 1. So until the battery, all right, or until what? The negative terminal of what? Of a battery. Because remember here, learners, we are using conventional current, which is from the positive terminal to the negative what? Terminal. So it's what you do when you are tracing current, right? So this ammeter, right? So which is what? 2 amperes, right? So this ammeter is the total current of what? Of the circuit, all right? So obviously the current that will pass through that R external is also what? It's also 2 amperes. So that 2 amperes is the total current of what? Of the circuit, right? What is given to us? Learners, we are given what? The potential difference across that R, all right? And please, learners, be careful. We are no longer going to use what? 12 volts. Remember, 12 volts is the EMF, right? And the battery has resistance or internal what? Resistance. So since the battery has the resistance, right? You will have the lost volts and the what? External. For what components in the external circuit, you will use what? V external, right? But for the internal, you will use what? V loss. That is very, very important, learners. So please be careful when it comes to that. All right. So we want resistance. So we want what here? Resistance. So we are looking for what? For resistance. Okay. We are given what? V external, which is what? 10 volts. We are given the total what? The total current, which is what here? 2 amperes. All right. So here we can use the equation R from the data sheet. So let's go back to our data sheet so that you see that this equation is there. Right. So this is our data sheet. The equation that I'm talking about is this one. R equals to V over what? Over I. I can even use this side, V over I. But what is this R, learners? Is external. So if you're having R external there, your V should be R V what? External. All right. Your I will be the total what? Current. Remember, this is another important formula when it comes to your electric circuits. This one. All right. So total current V external over what? Over R what? External. Okay, so R external equals to V external over I external. What is our V external is what? Is 10. And then total current is what? Is 2. Then our R external will be what? 10 divided by 2, which is what? 5 ohms. Okay, so our R external will be what? Will be 5 ohms. Very, very important, learners. So be careful on how you use these equations. Yes, I understand it's R equals to V over R. But which R are you talking about? Because now we are having R external, which is the resistance in the external circuit. You're having R internal, right? Which is the internal resistance represented by small letter R. So please be careful here. Please know which resistor are you referring to. Okay, that is very, very important. So now we are having R external as 5 ohms. So, and it was R external. Remember, it's R external and I've used V internal. I didn't use what? The EMF. The EMF, remember, is the total, unless if I was looking for the total resistance, all right? So the total resistance, then it was going to be what? EMF over what? Over total current. But I'm not looking for the total resistance, right? Remember my total resistance. This is very, very important, learners. Your total resistance now is no longer only, it's no longer what your R external, as we were doing before, right? Remember, we're ignoring internal resistance. Now we are no longer ignoring that. So your R external now will be R external plus what? Internal. This is how now you are going to calculate what? The total resistance. So please be careful. Total resistance is not only the resistance in the external what circuit. So it will be the resistance in the external circuit and also what is the internal what resistance. Remember, now we are not ignoring it. So your R total, please be careful. Your R total is no longer only the resistors connected in parallel or in series in the external circuit, but we also include what? The internal what resistance. This is how now we are going to calculate your R what? R total. Very, very important, learners. Please be careful of that. All right. So then we calculated our R and then we got 5 ohms. Then now they want us to calculate the internal what? Resistance. So how can we calculate the internal resistance? Let's go back. So these are some of the equations that we can use, right? These are some of the equations that you can use. We can use this one, right? Because we are looking for a what internal what resistance. Okay? Sorry about that. Right, it's fine. I can also use this space. Right, I want internal resistance. So I have I total equals to what here? V lost over what? Over R what internal. Remember, this is from R equals to V over I. Okay? So your R now is internal. That is why I'm having what? Remember, if I'm making I the subject of the formula, it should be I equals to what here? Equals to V over what? Over R. What is this V? Is lost volts, right? Because remember now I'm focusing on what? On the internal circuit, the battery. So in the battery, remember I have what? The lost volts or internal what? Voltage, right? Then this V will be V lost or internal what? Potential difference. This R will be what? Internal what? Resistance. So please be careful, learners, right? Please be careful when you use R equals to V over I. Know which R are you referring to? Which V are you referring to? Which I are you referring to? That is very, very important. Yes, we have R equals to V over I, but that R can be external, can be internal. That V can be EMF, it can be what? External potential difference, it can be internal what? Potential what? Difference. I hope you are aware of that. Then your I, it can either be the total current or it can be the current that passes through a certain what? Resistor or bulb connected in what? In parallel. That is very, very important. So, okay, let's go back. So our lost volts, how did you calculate that? Remember we said E minus what? Minus V what? External, right? Over what? R. Then here we're having I what? I total. Remember your E is given by what? V external plus what here? Plus V lost or V internal. So V lost, if you can make V lost the subject of the formula, it should be V lost equals to E minus what here? V external, right? So your E is 12, and then this one is 10. This is over R, and then here we are having what? 2. So if you are solving for R here, it will be 12 minus 10, then that will be 2. Then R multiplied by 2, cross multiplication, it should be 2R, then divide by 2, divide by 2. Your R will be what? 1 ohm. So this is what you were supposed to do for that for that question. All right. So I hope, learners, we are still together. Be careful. R V over I. Which R are you talking about? If it's total, then your V should be total, which is the EMF. Your I should be what? Total. If it's R external, then your V should be V external over I total. All right. If it's internal resistance, your V should be lost volts or internal what? Voltage or over what? Over the total what? Current. So please be careful when it comes to that equation, learners. All right. Then, so let's go back. Right. These are multiple choice questions. Right. right? You will also get multiple choice questions. You are aware of that. So question 1, it's multiple choice questions, 10 questions out of how many marks? 20 marks. So you are all aware of that in both papers, your paper 1 and your what? And your paper 2. Right, so consider the 3 circuit components represented below. Which one of the options below best represents the names of the components in the correct sequence from left to what? To right. So from your left to right, this is a battery, learners, or so not a battery, but a cell, right? So this is a cell which provides energy in a circuit. This is a rheostat. Rheostat or a variable resistor which regulates current in a circuit or which changes current in a circuit. And then this is a bulb which glows when current flows through it. All right. So we are having a cell, we are having a rheostat or a variable resistor which changes current. So that they will ask you the function of what? Of a rheostat in a circuit. So it changes what current in a circuit, or it regulates what current in what in a circuit. Then we are having a bulb which glows when the current passes through it. All right. So which sequence is correct? A cell. So it will be a cell, a variable resistor, and what? And the light bulb. So the correct answer here will be what? Will be D, learners. So again, it's very, very important to know the names of those components, right? So if you don't know them, unfortunately, you are going to lose marks sometimes, right? That is very, very important. And you should know the functions of each, right? So know how it is represented in a circuit, the symbol of it, the SI unit of it, all right? So, and also the function of that component. So that is very, very important, learners. All right, let's move to the next one. There's another one here. Circuit 1 shows, this is our circuit 1, all right? So circuit 1 shows 2 identical lamps, X and Y. So they're identical, they're having the same resistance connected to a cell of a negligible internal resistance. So the internal resistance is ignored in this case. Switch S is what is closed. So since the switch is closed, then the current will flow. So the current will flow. Then we are having circuit 1 and we are also having what? The circuit 2. So what are they saying about circuit 2? But before that, one, you will see that X and Y, they're connected in what? In series, all right? Even when it comes to circuit 2, X and Y, they're connected in what? In series. How are you going to do? How are you going to detect that? You trace current. Current flows as one. So these resistors are connected in what? Or they're not the resistors, but the bulbs. They are connected in what? In series. That is very, very important. Then what are they saying about circuit 2? A wire T of negligible resistance is connected across X as shown in circuit 2, right? Which one of the statements below best describes how the brightness of the lamps have changed after T has been connected, right? So let's go back to the circuit. So you can see that across X, a wire of negligible resistance is connected. So in other words here, learners, this is what we call short circuiting, right? So in other words here, they are removing what? Bulb X. Why am I saying bulb X? Remember, bulb X has a certain resistance. So there's no way that current will choose to pass through X, right? While wire T has no resistance. So current will only choose a path where there's zero what? Resistance. So there will be no current that will pass through X. The current will just choose this path because wire T has negligible what? Resistance, or it has zero what? Resistance. So there's no way that current will choose a path where there's resistance, while there's a path without what? Resistance, or with zero what? Resistance. So there will be no current that will pass through X, right? So if there's no current, so this one, it won't light up, because obviously there will be no current that will pass through it. Why am I saying there will be no current? Remember, wire T has negligible resistance, or it has zero what? Resistance. So current will just choose that path where there's no what? Resistance. There's no way that current will choose a path with what? Resistance. Remember that bulb has a certain resistance, right? But there's a wire connected across it, okay, with what? Negligible what? Resistance. So it won't light up. But what about X, right? Remember, learners, here, if I'm having 2 ohms, remember they are identical. What will be the total what resistance in this case? It will be what? 4 ohms. You are aware of that. Rs equals to R1 plus R2. Okay? But if now I'm removing this bulb, I will be left with only what? This 2 ohm. So which means that my R total here, learners, will be what? Will be 2 ohms. Right? So what am I trying to say here to you, learners, is that if you remove a resistor or a bulb connected in series, what happens to the total resistance of the circuit? The total resistance of the circuit will what? Will decrease, right? So initially, you had X and Y. What was the total resistance? It was 4. But now we are connecting a wire of negligible resistance across X. Then there's no way that current will choose to pass through X, while there's wire T with 0 resistance, all right? So all the current will just pass through that wire, but remember that Y is still there, right? So which means that if we have, or we had the resistance of Y as 2 ohm, right? Then what was going to be our R total or total resistance? It was going to be what? 2 ohm. So you can see now that if we remove a resistor connected in what? In series, what happens to the total what total resistance? The total resistance will what? Will decrease. Okay. Then if the total resistance decreases, according to the equation, R equals to V over I from our formula sheet, right? Remember, R total will what? We are saying it will decrease when it comes to circuit 2. Okay? So if R total decreases, R, remember, is given by V over what? Over I. This is R total. This should be total. This should be total. So what is this total? Remember, it's the EMF. And remember, EMF of a cell or EMF of a battery always remains what? Constant. There's nothing that we can do to change the EMF of a cell. So EMF of a cell, if we are told that it is 12 volts, there's nothing that is going to happen. There's nothing that you can do to change the EMF of what? Of that battery or the what? Of that cell. All right. So this will be the EMF. So this remains constant. All right. In this case. And we are saying this will decrease. If this decreases, which is our R total or total resistance, what will happen to I total? The I total will what? Will increase for constant EMF. So if I total increases, let's go back to that circuit. Very, very important. Right? If I total increases, which means that the current now that will pass through Y, or the current that will pass through bulb Y will be more than before now. All right? It will be more than before. So, which means that this one will be brighter than before. I'm not sure whether you're following, right? This one will be brighter than before. But where did this start? Remember that wire is connected across across X. So, and that wire has 0 watt resistance. So since it has 0 resistance, the current will just pass through that wire. Then in other words, we are eliminating or we are removing what? X. Okay? So we are removing X, right? So if we remove X, what happens to the total resistance? We are removing a resistor or a bulb connected in what? In series. What happens to the total resistance? It will what? It will decrease. And if total resistance decreases, right? What happens to total current? Total current will increase at constant what? EMF. And if total current increases, what will happen? Right? Remember here now we are talking about the brightness, right? So if total current increases, P, what remains constant is the resistance. P equals to what here? I squared what? I squared R. For wire, sorry, not for wire, but for bulb Y, what remains constant? It is what? The resistance is still the same, right? Then, what did we say about current that will pass through Y? We said the current that will pass through Y will what? Will increase. Then if the current that passes through Y increases, then what about power used by Y? It will also what? Increase. Or power dissipated by Y, it will also what? Increase. So if power increases, what about the brightness? The brightness will also what? Increase. So it will be more what? Brighter, or it will be brighter than before. Right. So if you want to talk about the issue of brightness, right? Brightness is proportional to what? To power. Okay? Brightness is proportional to what? To power. So check here what I did there. Right? What happens to the total resistance? I said the total resistance will what? Will, because obviously if we remove a resistor, the first thing that will be affected, it should be what? the total resistance. So we said the total resistance of the circuit will what? Will what? Decrease. If the total resistance of the circuit decreases, what about the total current? Increases at constant EMF, right? So if total current increases, what will happen now to power? Which equation are we going to use? P equals to I squared R. Why am I choosing P equals to I squared R? It's because for Y, what is constant is R. The resistance is still the same, all right? So if the resistance is still the same, we said the total current here will what? Will increase. If the total current increases, what about P? P will also increase. If P increases, what about brightness? The brightness will also what? Increase. So we are saying X won't light up. This is correct. It can't be brighter, it can't be brighter, it won't light up. Is Y going to be dimmer? No, it can't be dimmer. This is also already out, right? But Y will be what? Will be bright, right? Y will be brighter. Why? Y will be brighter. Remember, there was that increase in current. If current increases, what about power? It will also increase at constant R. All right. So the correct answer here, learners, would be what? Will be D. Okay. So now let's focus on this. These are the steps, learners, that you can follow, right? When solving problems of electric circuits with internal what? Resistance. These are the steps that you need to follow. If you are not given a diagram, right, you need to draw what? A diagram. Identify whether there's internal resistance or not. If there's no internal resistance, remember EMF is equal to the terminal potential what? Difference. But if there's internal resistance, your EMF will be V external plus V internal. So by now you are aware of that, which is this. Then we can expand this to what? Remember your EMF, we are saying it's V external plus what? V lost or V internal, right? How to calculate V external is IR external, all right? Plus what? V lost, which is I small letter r, right? We can take out the common factor because I there is the total current. Then it should be I into R what? External plus what? Plus internal. So this is how we calculate E if there is internal what? Resistance. Okay, so very, very important. But when it comes to your formula sheet, it's just I into R plus small letter r. But you should know that that big R is external resistance, that small letter r is the internal what? Resistance. So it's what we need to focus on. Right, then, yeah, we are given this circuit. These are exam type questions. A battery with an EMF of 20 volts. So we are given EMF here. It's 20 volts, all right? And an internal resistance of 1 ohm. So we are also given what? The internal what? Resistance. So like it or not, your EMF, your E will be what here? V external plus what? Plus V lost. Okay? Why am I saying that? There is internal what? Resistance. Then these resistors, this resistor and this one, these are your external what? Resistors. So they will form what? R external. And then this one would be what? Internal. Okay, which is your small letter what? R. Then for these resistors, remember, we use what here for these resistors? We use V what? External. And then for this resistor, we use V what? Internal. That is very, very important. Okay. Then another thing, learners, which is very, very important here. Remember, one, you must identify which resistors are connected in series and which resistors are connected in what? In parallel. Remember, your internal resistance is always connected in series. Since it is always connected in series, the current that will pass through the battery will be the total current of the circuit. Why am I saying that? Resistors connected in series, they don't divide current, but they divide the potential what? Difference. So which means that the current that will pass through the battery is always the total current of the circuit. Why am I saying it's always the total current of the circuit? That resistor or that battery is connected in what? In series. Or that those cells are connected in what? In series. Right. So let's trace current. So when we trace current, we are moving from what? From the positive terminal to what? To the negative terminal. So current is moving as one until that 8 ohm resistor. So the 8 ohm resistor, learners, is connected in what? In series. So let's trace current. Then you can see at this point there was a split. All right. So since there's a split there, it means that your 10 ohm resistor and your 5 ohm resistor, they are connected in what? In parallel. So then current here will be divided, right? But potential difference will be the same. Okay. So current is still divided until that point, né? Right? Then the current that will pass through the battery will be the total current of what? Of the circuit. So learners, it's very, very important to detect which resistors are connected in series and which resistors are connected in what? In parallel. But to do that, please make sure that you trace current. Sharp. Then, if you can check here, there's a lot that you can do without looking at the questions, right? One, you are given what? All the resistances, right? You are given the internal resistance, you are given what? The external what? Resistance. So what we can do here, one, we can calculate what? The external resistance, we have the internal resistance, we can also calculate what? The total what? Resistance. How are we going to calculate what? The external. We want the external, which is what we know how to calculate by now in grade 10. We want the external. So for the external, the resistance in the external circuit is your 5 ohm, your 10 ohm, your 8 ohm. Your 8 ohm is in series. Your 5 ohm and your 10 ohm, they're connected in what? In parallel. So start with parallel connection. So it's 1 over what here? Over Rp equals to 1 over what? R1 plus 1 over R2. So remember, learners, you don't substitute from the atmosphere, right? You write down the equation. Where is this equation coming from? From your formula sheet, all right? So copy that equation as it is and then write it, and then from there you can substitute, right? So I'm having 1 over what here? Over 5 plus 1 over what here? Over 10, okay? Then that is your 1 over what here? Over Rp, okay? So you have your 1 over Rp equals to 1 over 5 plus what? Plus 1 over 10. So what is 1 over Rp? Okay, your 1 over Rp will be what? What is here, your common factor here, I think it should be what? It should be 10, then 2, then here plus what here? Plus 1, right? Okay, then you will have what here? 3 over what? Over 10. But remember, learners, that is your 1 over Rp. Then your Rp will be the inverse of 3 over 10, which is 10 over what? Over 3. So that is your Rp. Then 10 over 3, I think it should be maybe 3.33. All right. So that is very, very important. So now I'm having my Rp, and I'm not supposed to actually to do what here? To round off this answer. So that is why I left it as 10 over what? Over 3 ohms. So now, learners, I'm having a circuit like this one now. I'm having a 8 ohm resistor, and then I'm having parallel connection. And for parallel connection, what did I get? I got what? 10 over what? Over 3. Where is that 10 over 3 coming from? Is for the parallel what? Circuit. Ne? So you can see that now your parallel is in series to this 8 ohm resistor. So how am I going to get the total? Not the total, but the R external. Your R external will be R series plus R what? Parallel. So what is your R series? Your R series, remember, it's 8 ohm resistor, which is now in series with that R parallel, which is 10 over what? Over 3. Then you will get your answer in what? In ohms. So this is how you can get your R what? Your R external. Okay? So you have 8 plus plus 10 over what? Over 3. Then you'll get your answer in what? In ohms, which is maybe 13, not 13, but 11.33, for example, right? I hope it's 11.33. But what is this 11.33, learners? Is the R what? External. Then remember, now I want R total. I said R total now will be R external plus what? Plus internal. Your R external, you calculated, you saw how we calculated our R external. We got what? Maybe 11.33. Then plus 1. Where is this 1 coming from? We are given the internal what? Resistance. So then you will get maybe 12.33 what? Ohms. So remember, your learners, you have your internal resistance and your external. So your R total, it will be R external plus what? Plus internal. Okay? Then, okay, what are we having now? We are having internal, we are having external resistance, you are also having the total what? Resistance. Fine. So since we are having the total resistance, we can calculate the total current. All right? So total current, there are 3 equations that we can use, right? You have R equals to V over I, where R can be R external, all right, equals to V external over what? Over I what? Total, all right? or where R is internal equals to V lost over what? Over I what? I total. Or R total equals to V total over what? Over I total. These are the equations that you can use. But remember, all of them, they're from R equals to V over I. What is this R? R external, V external over I total. What is this R now? We are focusing on the internal circuit now, where we are having internal resistance. So it's internal resistance equals to V lost over I total. Okay? Then R total equals to V total over what? Over I total. Then when I check this one, I have R what? External. Do I have V external? Then we go back. Do I have V external there? Right. Do I have V external? No, I don't have V external. The only thing given to me is what? Is the EMF. Alright? So then, since it is the EMF, then I will have how many unknowns if I want to use this one to get the total current? I will have 2 unknowns. Alright? Then, if I use this one, how am I going to get lost volts? Am I given lost volts? No, I'm not given lost volts. Although I'm given this, but I don't have lost volts, so I'm going to have how many unknowns? 2 unknowns. I don't have V lost, I don't have I total. But with this one, now I have R total, right? So I have R total. What is R total? Already I got 11.3. I can calculate that. Ne? What is this? Is the EMF. Already I'm given what here? EMF. I think EMF is what? Is 20. So can you see that I can get the I total there? So my I total from here, it should be 11.33 equals to what? V total, which is EMF, 20 over what? Over I total. Then I can get my I what there? I total. I hope you can see that. So these are the equations that you need to use, learners. Yes, I understand it's from R equals to V over I, but which R are you focusing on? Which V are you focusing on? Which I are you focusing on? That is very, very important. Then current in the 8 ohm resistor. Current in the 8 ohm resistor, it will be the total current of the circuit because that 8 ohm resistor is connected in what? In series, right? Even the current in the battery will be the total current of what? Of the circuit, all right? Then we can calculate the potential difference across the 5 ohm resistor. Ne? So the potential difference, so learners here, it will be what? I will just use these values as they are. 20, is it 20? Yes, 20 over 11.33. Then you'll get your answer in what? In amperes. That will be the total current, which will be the current that will pass through that 8 ohm resistor. Can you see 6 marks? So where are you supposed to start? And please, learners, be careful. You don't calculate what from your head, right? You can do that, but remember, for you to get marks, you must show all your calculations. So in most cases, learners, they will just calculate from their head and then they won't even show where some of the answers are coming from. So remember, you are going to lose marks if you are going to do that. So write everything down so that you can get marks. So the reason why here we're having that 6 marks is because you started by calculating R external. Then from R external, we calculated what? R total. Then from R total, right? You can now calculate what? I total because you have given the EMF of V total. Okay, that's the reason why it is 6 marks. Then they want the potential difference across the 5 ohm resistor. Ne? Okay. Across the 5 ohm resistor. Okay, I want to go back. Right. So across the 5 ohm resistor, so this 5 ohm resistor, learners, is connected in what? So they want the potential difference there is connected in what? In parallel. Right. So since it is connected in parallel, 1. Learners, remember I said to you, they want the potential difference. What did I say to you? We got what is this? We got okay, we got that you have your 8 ohm resistor, right? And then here we know we are having 10 over 3. Where is that 10 over 3 coming from? Remember, it's for resistors connected in what? In parallel. So the current that will pass through this one, right, will be equal to the current that will pass through this. So already we are having that current, all right? So if you are having that current, you can calculate the potential what? Difference. So the potential difference, it will be again R equals to V over what? Over I, right? So, but what is this R, learners? Is for R what? Parallel. What is this V? Is for V parallel. what is this I, right? Is for I what? Parallel. Obviously, it will be the total current in this case, because now that I parallel, I got the total of it is 10 over 3. So it will be Rp equals to V parallel over what? Over I total. Then what is my Rp? My Rp, it's what? Is 10 over what? Over 3. And then V parallel is what I'm looking for. And then I total, I got I total. Okay. What was my I total? I total, it was 20 over, is 20 over 11.33. Then you can get your V what? Your V parallel. That is one method that you can use. Another one that you can use, let's go back and check. Right. Another method maybe that you can use. Already, okay, you know the current here. Right? This is the total current of the circuit. So what you can do, you can calculate what potential difference across that 8 ohm resistor, right? How are you going to do that? Potential difference across 8 ohm resistor. It should be IR. From V, not from V, but from R equals to V over what? Over I. Alright? So your potential difference across 8 ohm resistor, the total current, right? So for total current, you got 20 over 11.1.33. What is R? We are calculating the potential difference across 8 ohm resistor. So your R will be what here? 8. Then you will get that potential what? That potential difference. So the potential difference here across 8 ohm resistor, right? So you calculate and then you get your answer in volts, right? Then remember, you have what the potential difference there, okay? Then if you have the potential difference, what you can do, but that will be your V what? Your V parallel, ne? So another thing is that you can do, remember you have the total current, you can also calculate the loss volts, all right? So you can calculate the loss volts, which is your what? Your IR. So your IR, it's 20 over 11.33 multiplied by what? I think we're given the internal resistance, which is 1. Then here we have what? 20 over 11.33 what? Volts. So you have lost volts. So E equals to what? V external over what? Sorry, plus what? Plus V lost, right? Then your V external will be what? E minus what? V what? V lost, right? So E, remember, is 20. V lost will be what? 20 over 11.33. Then you will get what here? V external, right? Then after getting your V external, although it is a long method, but remember your V external now, remember these resistors, we have resistors connected in series and resistors connected in what? In parallel. So you'll have your V external equals to V parallel plus V series. Then your V external, the value that you got there, you have it, right? Then you want V parallel. Then already you have calculated the potential difference across that 8 ohm what? 8 ohm resistor. That would be your V what? Your V series. Ne? So you'll have this, then you'll get your V what? Your V parallel. So it's another method that you can use, but it is what? A long method. But I showed you the shortest method. Alright. So yeah, this is what you're supposed to do. Then you'll get that. Then they want you to calculate the total power supplied by the battery. So the total power supplied by the battery, there are equations, right, that you can use. So for the battery, what are we having for that battery? What are we having for that battery? Go, let's use the formula sheet. We are using the formula sheet, right? Okay. Yeah, so these are the equations that you can use. So for the battery, you are given the potential what? Difference. So which is what here? Which is 20, right? So it will be 20 multiplied that by what? The total current, because the current that will pass through the battery will be the total current, which is what we got is 20 over what? Over 11.33. Then you'll get your answer in what? In watts. Okay, so I'm not going to calculate answers for you. You can calculate them at home. It's still fine, right? Then it's 20 times 20 over what? Over 11.33. Then we'll get power delivered by what? By the battery. So P equals to VI. V is the potential difference in a battery, which is the EMF. I, it will be the total what? It will be the total what? Current. Okay? Then that will be the total or what power delivered by what? By the battery. Okay? So the equations are there. So let's check the second one. Energy dissipated by 10 ohm resistor in 2 minutes, right? The equations for energy, they're also there, right? So you can use this one, VI what change in T. Your V in that 10 ohm resistor, already we have calculated. Remember, if the potential difference across 5 ohm resistor, right, is 10, even here it should be what? 10, because that 5 ohm resistor and the 10 ohm resistor, they're connected in what? In parallel. So for parallel connection, potential difference is the same. So you use that potential difference, which is the V parallel, and then you'll use the current that passes through the 10 ohm resistor, right? So which means that you need to start by calculating that current, okay? And you can do that because already we have the potential difference, right? We have the resistance, then you can calculate that current. Then time here, learners, is in seconds. So 2 minutes is how many seconds? 120 what? Seconds. Then you'll get your answer in what here? In joules. That is very, very important. Another equation, work done, that is energy, it will be V squared over what here? Over R. Okay? So V squared change in T. And where are you getting these equations from the formula sheet? So V squared change in T over what? Over R. So V squared, remember, we want energy dissipated by the 10 ohm resistor. So we want the potential difference across that 10 ohm resistor, which is what we calculated there. All right. So you'll use that and then you square that. All right. Then time is 2 minutes, which is 120 what? Seconds. And then R. What is R in that 10 ohm resistor? Is what? Is 10. Then you'll also get your answer in what? In joules. Okay. Another equation, it will be work done equals to what? I squared R change in T. So your I, it means that you will start by calculating current that passes through that 10 ohm resistor. Then your R is 10 and then time is what? Is 120 what? Seconds. So the equations, learners, they are there. All right? The equations are there. Then the last question, they want us to calculate the cost. Sorry about that. Yeah, they want us to calculate the cost of using the 8 ohm resistor for 5 hours. If the cost per unit is what? Is 2.86 rand, right? Learners, I hope you still remember how to calculate the cost of electricity. Né? The equation is not there on your formula sheet. So the cost, right? Allow me to use this space. So the cost will be what? Energy in kilowatt hour. Energy in kilowatt hour multiplied by what? The tariff. Or this is just cost per unit or cost per kilowatt hour, right? So one, you have cost per kilowatt hour, okay? You have cost per kilowatt hour. The cost per kilowatt hour is 2.86 rand, right? So it's 2.86. And then you have time in what? In hours. And then for the 8 ohm resistor, this is what you need to do when you calculate the cost of electricity. You need energy in kilowatt hour, right? Energy in kilowatt hour. So how are you going to get that? First thing that you need to do, you calculate power dissipated by what? By that 8 ohm resistor. Ne? Obviously, the power that you're going to get, you can use VI, you can use what? I squared R, so any equation, okay? So if maybe you're using VI, right? So you need potential difference across that 8 ohm resistor, okay? Then your potential difference across that 8 ohm resistor is what you'll use there, and the current that passes through that 8 ohm resistor, because you want power. It's the first thing that you need to do. Power dissipated by the 8 ohm resistor. Ne? So you will calculate what you need what the potential difference across that 8 ohm resistor. You need the total current, which is obvious because it is connected in what? In series. then you'll get your answer in watts. All right? Then what do? You convert watts to what? To kilowatts. For example, let's say here you're getting 8 watts. Then how do you convert from watts to kilowatts? You just multiply that by what? By 10 to the power negative 3, or you divide by 1000. Okay? So which means that here, now you will have what? 8 times 10 to the power negative 3. That is kilowatts. Remember, we want energy in kilowatt hour. So you need to multiply by hours. So if you are given time in minutes or days, for example, you need to convert days, or you need to convert minutes to what? To hours. So fortunately here we're given time in what? In hours. So we are going to use that 5 as it is. So that is 5 hours, right? So then it will be what? 8 times 10 to the power 3 times 5, okay? Then you multiply that by tariff, which is 2.86. Then you get your answer there in rands, or if they want it in cents, so it will depend on the examiner. So, but how do we calculate the cost of electricity? You need energy in kilowatt hour. First thing that you need to do, you calculate power. Power that you're going to get, it will be in what? In watts. Convert watts to what? To kilowatts. How do you convert watts to kilowatts? Right? You divide by 1000, or you multiply by 10 to the power negative 3. Obviously, now you will have power in what? In kilowatts. Then energy in kilowatt hour. So it will be that kilowatts, right? Which is power, multiplied by time in hours. Then you multiply that by the cost of cost per unit, or cost per kilowatt hour, or by tariff. Then you'll get the cost of using that appliance for certain hours. All right. So it's what you need to do, learners. Then this is another circuit, right? Another circuit. And then again, with this circuit, what is important here, again, you can see that we are given the internal what? Resistance. All right. But we are not given what here? The EMF. All right. So in the circuit diagram below, the battery has an EMF, right? And an internal resistance of what? Of 0.8. But we are not given what? In this case, the EMF. All right. So since you are not given the EMF, then it means that somewhere, somehow, they will want you to calculate what? The EMF. But there's something that is given to you. Check here. Let's trace current. Tracing current. Then there, learners, there's a split. All right. So you'll see that this resistor and this resistor are connected in what? In parallel. So then current here moves as 1, then moves as 1. So which means that the current that will pass through that 5.8 ohm resistor will be the total current of the circuit. Then, right? So it moves as 1, 1 until that ammeter. There's an ammeter there. Then until what? The battery. Then what is given here? Before they ask questions, you will see that here you are given A2, right, which is 0.6 amperes. What is this 0.6 amperes? It is not the total current of the circuit, but it is the current that, remember there was a split there, which means that current is what? Is divided. So which means that this 0.6 amperes will be what? The current that will pass through 4 ohm resistor, right? So since we have the current that passes through 4 ohm resistor, we can get the potential difference across 4 ohm resistor, which would be the V parallel, or the potential difference across parallel connection. So we can get that. So you can get V1 using IR. What is your I? 0.6. What is R? Is 4. Because this 0.6 is the current that passes through what? The 4 ohm resistor. Then we'll get that V. Okay? In what? In volts. Right? So getting that V, already we are having potential difference across this 6 ohm resistor, because this V1, it is the potential difference across 4 ohm resistor, the potential difference across 6 ohm resistor, because they're connected in what? In parallel. So you have that. You have that V, which means that you can calculate what here? Current. So the current will be your what? Your R equals to V over what? Over I. So R will be 6 ohm, your V will be that V1, right? Then you calculate I. Then I for 6 ohm resistor plus I for 4 ohm resistor. When you add the two, you must get the total what? Current. Then come to this one, you have the total current now. You can calculate this V2. I hope it's clear, right? Calculating V2, because remember I, where is this I total coming from? Is I total when it comes to 4 ohm resistor, and is I when it comes to 4 ohm resistor, and I when it comes to 6 ohm resistor. Combine the two, you'll get the total. which will be the current that will pass through that 8 ohm resistor, right? Then we can calculate V2, right? So that V2 will be this resistor, the resistance of this resistor multiplied by the total current. Then we get V2. And remember, your V1 plus V2 will give you what? V external. I hope it's clear. Your V1 and V2 will give you what? V external. So already you have V external, you have total current. Remember, you have total current. You can calculate what? V lost. Because you are having internal resistance, right? You are having internal resistance and the total what? And the total current. So I have the total current, I have the internal resistance. I can calculate what? V lost. V1 and V2 will give you what? V external. You are having V lost, right? So then your EMF, remember, is V external plus what here? Plus V lost. So it's very, very simple. So before they ask questions, there's a lot that you can do. So, but what is important in us, please make sure that you trace what? Current. So trace current, you'll see which resistors are connected in series, which resistors are connected in what? In parallel. So as long as you understand your circuit, you understand which V you are talking about, which R are you talking about, which current are you talking about, you will never go wrong. Because in most cases, we just use values haphazardly, which is wrong. So if you are given current, check, is current through which resistor? Is it the total current? Is it the current that passes through a resistor connected in parallel? So those are the things that you need to check, learners. Very, very important. All right. So maybe we can check the questions now. You state Ohm's law. It is there on your examination guidelines. So you state it correctly and then you get what? 2 marks. Remember, they can mark it independently, right? Or sometimes they can decide maybe marking it and not maybe independently, which is going to be 2 marks or what? Or 0. So, but what is important? Make sure that you state the law correctly. Then the reading on the ammeter A2 is 0.6. You saw that. Then calculate the reading on voltmeter V1. V1, we said V1 would be IR. Then what is that I? 0.6 equals to multiplied by what? Multiplied by what? Multiplied by 4. Then it's what we're supposed to do. So I think we have a memo for this one. Yes, which is going to be this one. So let's check the second question. Current through 6 ohm resistor. 6 ohm resistor is connected in what? In parallel. So what is the same? So let's check here. What is the same is this potential what? Difference. So current V over I, V 2.4. Why 2.4 even for 6? Because they're connected in what? In parallel. So for parallel connection, remember potential difference is what? Is constant. Divide by 6, which is the resistance, then they go to 0.4. Right. Remember, learners, you are having that what now? 0.6 plus 0.4. Right? That's 0.6 plus 0.4, which is going to be what here? I think it's 1. That will be the total current of what? Of the circuit. So let's move to the next question and see. All right, reading on V2. So reading on V2, remember V2 is connected across that 5 ohm resistor, which is connected in what? In series. And for series will use what? The total current of what? Of the circuit. So let's check. Okay. Right. So V2 will be IR. Where is this I coming from? I showed you it's 0.4 plus 0.6 multiplied by the resistance of that resistor. Then they got what? 5.8. Remember, V external, learners, would be V parallel plus V series, right? V parallel, we got what? 2.4. V series, we got what? There, 5.8. You see that, né? So then you'll get what? Your V external, all right? So it will be your V external. Then your V lost will be what? IR. Your I is the total, which is 1. But here, remember, a small letter R, né? And then this one is 0.8. Then we have 0.8 watt volts. Then your EMF will be V external plus V what? Internal. Then you'll get your what? Your EMF, which is going to be the next question. So this is what they did here. They added the 2 voltmeter readings for series and parallel. This is for series, this is for parallel. Then they got what? 8.2. Then they calculated what? V internal, 0.8. Then add the 2, then the EMF of this cell is what? Or of this battery is what? Is 9 volts. So let's check the last question. Right, the last question. Energy dissipated as heat inside the battery if current flows in the circuit for how many seconds? 15 seconds. So energy. The equations for energy, learners, that are there on your what? On your formula sheet, right? So you can choose any, right? Any equation. But the one that is the energy dissipated as heat inside the battery if current flows in the circuit for 15 seconds. All right, let's check because we are running out of time. Then the last question, using V, so work done, or energy equals to VI change in T. So, and then the potential difference, 0.8, right? And then remember this 0.8 is the lost volts, all right? And then the current is the total current, time 15 seconds, then they got 12. Using this one, total current, R in the battery is that internal resistance, which is 0.8, then time is 15. So it's another method that you can use. So also you can also use this one, V 0.8, which is the lost volts, and then time is 15 seconds, and then R is the internal resistance, because remember we are dealing with a battery here. So if when we talk of R, it should be the internal resistance, all right? If we talk of V, right, it should be the lost the lost volts. Okay, so that is why here they've used for example, when it comes to this equation, total current 0.8, which is R in small letter R, internal resistance, and then time is 15 seconds. So this is what you are supposed to do learners. Then I think this is enough for today, learners. So let's call it a day. Please don't forget, learners, to practice, use the past question papers. All right, they will assist you. Check if you did understand this topic. But remember, when it comes to your grade 12, all right, when it comes to your grade 12, we include the internal resistance. So you should know what happens immediately. Internal resistance is not ignored. There will be two circuits, internal, external. Coming to that equation, R equals to V over I. Know which R are you talking about, which V are you talking about, which I are you talking about, right? Then your EMF now will be divided, right, into V external and V what? V internal, V external or what? Or V loss. So those are some of the things that are very, very important when it comes to electric circuits and in grade 12. But other than that, whatever you did in grade 10, grade 11 is also tested in grade 12. So here we just add internal resistance. So have a blessed day. Thank you very much, learners. Goodbye.